In the incredible, sprawling world of nature, every single species has its own unique playbook for survival. But how do we actually figure out what that playbook says? Well, today we're going to dive into the amazing tools that ecologists use to decode the basic patterns of life, death, and all the strategies that drive evolution. And it all really kicks off with this one simple question that makes you think. Why in the world does an oyster throw millions of eggs out into the ocean, just hoping for the best, while an elephant pours years and years of care into just one baby? The answer to that question reveals two totally different, but, equally successful approaches to life on this planet. So here's our roadmap for today. We're going to start by figuring out how to decode survival using raw data. Then we'll get into the ecologist's go-to toolkit, the life table. After that, we'll see how that data tells a visual story with survivorship curves, connect those stories to the big ideas of R and K selection, and then wrap it all up to make sure you've got these concepts down cold.
Okay, so how does a scientist go from just watching a single deer in a forest to actually understanding the survival patterns of the entire species? Well, the answer is a field called demographics. It's the science of turning those observations into solid numbers, into hard data that tells us the hidden stories of life and death.
And the first and honestly most important tool in our toolkit is the life table. The best way to think about it is like an ecologist's accounting ledger. It's this detailed book that keeps track of everything: births, deaths, and survival rates for a population across its entire lifespan. At its heart, a life table is really just a super powerful summary. It lets us systematically track a group of individuals age by age and figure out the exact probability of making it from one year to the next. It's the absolute bedrock of population analysis. Let's quickly break down what we're looking at. X is just the age group we're talking about. The column you really want to pay attention to is LX. That's the one that tells us what fraction of the original group is still alive at that age. And here's a super important rule. LX can only go down. It never goes up. And finally, HUX is the mortality rate, basically the flip side of survival. Now, ecologists have two main ways of building these tables. The gold standard is the cohort table, where you literally follow one group from birth until the very last one dies. It's incredibly accurate, but as you can imagine, it's often just not practical. So what's more common is the static table. It's just a snapshot in time. It's way faster, but, and this is a big but, it has to assume that survival and death rates have stayed the same over time. That's a huge limitation to keep in the back of your mind.
Life tables give us the hard numbers, which is great. But their real power, the wow moment, comes when we turn them into a picture. By plotting this data, we can create something called a survivorship curve, a single line that tells the entire story of how a species tackles survival.
So a survivorship curve is simply a graph. It plots age against the number of survivors. You'll often see the vertical axis, the y-axis, on what's called a logarithmic scale. That's just a clever trick that makes it easier for us to compare species that have really different lifespans. And with just one glance at this graph, you can instantly see a species' life strategy. First up, we have the type I curve, which I like to call the survivor. For these organisms, there's a really high chance of making it through the early and middle years. Most of the deaths happen when they get old. This is the classic strategy for species like us and elephants. You invest a ton of energy into just a few offspring to make sure they survive. And here is a super important insight, especially for those of you studying this stuff. For a type 1 species, making it to adulthood is pretty much expected. The real scientific puzzle, and where a lot of research is focused, is figuring out what causes mortality after they're done reproducing. Next is the type 2 curve. See how it's just a straight diagonal line? That represents a constant risk of death throughout an organism's entire life. For something like a bird, the danger of a predator is just as real on its 10th day as it is on its 1000th. Basically, death can come at any time, regardless of age. And finally, we're back to our oyster with the type 3 curve, or the Great Gamble. Look at that massive drop right at the beginning. That represents an incredibly high death rate for the young ones. But, and this is key, for the very few who survive that early phase, their chances of living a good long life are actually pretty high. It's the ultimate strategy of quantity over quality. So these three curves, they aren't just random patterns. No, they're visual clues to much deeper evolutionary strategies. And they lead us right into one of the most fundamental concepts in all of population ecology, the theory of R and K selection. It really is a tale of two strategies,
On one side, you've got your R-selected species. They are all about quantity. They do great in unstable environments, and they almost always have that type 3 survivorship curve. On the other side, you've got the K-selected species. They're all about quality. They prefer stable, predictable environments, and they show that type I curve.
This table right here is your new best friend for studying this. It just lays out all the trade-offs perfectly. You can see the pattern, right? Our strategists go for tens of offspring, no parental care, and they tend to be small. K strategists, on the other hand, invest everything in just a few offspring, which means lots of parental care and usually a much larger body size. Each strategy is just perfectly suited to its environment.
Okay, now for a really critical piece of nuance, one that gets tested all the time. R and K selection, they are not two separate, rigid boxes. You have to think of them as two ends of a long spectrum. Nature is filled with species that fall somewhere in the middle, mixing and matching these strategies. The real world is always more complicated than simple categories. All right, let's pull all of this together. In this last section, we're going to combine everything we've learned, and I'm going to point out a few common traps just to help make sure you've really mastered these ideas.
Let's wrap up with 3 common mistakes you want to avoid. First, don't assume that just because an animal is big, it must be a K strategist. Nope. Think about the giant ocean sunfish. It lays millions of eggs. Second, please don't mix up a survivorship curve with a population growth curve. They measure totally different things. And last, never ever forget that R/K selection is a spectrum, not a simple either-or choice. So, what's the one big idea to take away from all this? It's simple. Life tables give us the numbers, survivorship curves give us the picture, and both of them reveal the deep R and K strategies that shape the entire natural world. It's data, picture, and strategy. And I want to leave you with one final thought to chew on. We know that K strategists, our elephants and so on, they're built for stable environments. So in a world where our environments are becoming more and more unpredictable, are these amazing survivors doomed? It's something to think about. Thanks so much for joining me.